we can discuss about the job roles also, which are related to the time series. Okay, I hope so it's okay for you, CZ. And yeah, so this way we have the data set x1, y1, x2, y2, x3, y3, and so on, right? So till now what we have seen that on x1 this value is dependent, right? On x2 this value is dependent. On x3 this value is dependent. But what we are going to see is that this is not the case always, but on y1 y2 is going to be dependent, and on y2 y3 would be dependent. When we have such a case, then we have the time series, so we cannot use the normal thing, right? Okay, I will pause for a moment. Actually, there is some issue with the YouTube broadcast, so I will just pause for a moment and then we will start the session in few moments. Okay, I will start once again from the beginning because it has been requested, because there have been some issues with the YouTube broadcast. So let me just confirm once it. Okay, so everyone, welcome to the lecture series of data science by Edureka. And today's topic which we are going to discuss is time series analysis. So till now we have seen some supervised learning algorithm, unsupervised algorithm, and now we are going to see time series analysis, where we have special kind of data which is dependent on time. We'll see exactly what kind of data it is, right? So let's see what are the topics which we are going to cover today. We will start discussing with why time series analysis is needed. Then we will discuss about what is time series. Then we'll see some of the components of time series. Then we will discuss when not to use the time series and what is stationarity. So stationarity is one of the important condition when we apply our specifically ARIMA model, which we are going to see here in the next slide. And at the end, we'll see some demo for doing some kind of feature forecasting. Okay, so let's discuss why time series, right? So in the analysis, you just have one variable time. So what we are going to see that till now we have been discussing about x1, x2, x3 are the independent variable, and y is the output variable or dependent variable, we can say. But now what we are going to see is we will have a time as independent variable, right? So we will be having a time which is going to be our independent variable, and then we will be having some value dependent variable by depending on which kind of application it is. It might be like sales value or anything, right? Whichever you want to do as a prediction, or temperature even, right? So let's say here normally what happened, we have the x1, adding x1 we say y1, then we say when the value is x2 then y2, when the value is input variable value is x3 then y3, right? So here what we see that y1 is dependent on x1, y2 is dependent on x2, y3 is dependent on x3. This is what we have been discussing or doing till now. But here not is the thing which is going to happen is that y3 not only dependent on the x3, but it is dependent on its on previous value, right? So that is where our time series analysis is coming into the picture, where we say that it is time dependent. So what would be the tomorrow's stock value? That is going to dependent on what is today's stock value, right? If I talk about what would be the TCS stock price for tomorrow, right? That is going to be very much dependent on what was the stock price of today and what was the stock price of yesterday's. So more it would be dependent on the today's, right? So whenever we have such case that the tomorrow's price dependent on the yesterday's price or today's price, then we have the time series analysis, right? So you can analyze the time series data in order to extract meaningful statistics and other characteristics, right? And what is time series? So some of you might have already understood. A time series is a set of observation taken at specified time, usually at equal intervals, right? So if we are talking about the cases wherever in our data set independent variable is time, then we call it as a time series data, right? So time might be in any form. It might be in the form of second, it might be every minute I take some value, it might be every hour I am taking, or it might be monthly value we are taking, or maybe yearly value we are taking. It depends what particular application we are working with. Let's say if I am working with the stock market, then every second we take the value and we see how much value changed or what is happening in the stock price. Let's say if we are talking about temperature value, we may be taking every hour, right? And let's say if I am talking about the sales of my company, right? Let's say I have a company which let's say which sells cloths, right? And then what I will look maybe every month I want to see how much sale has been done by our company, right? So that is different cases, but in all these cases the factor which is independent variable is the time, right? Whatever time interval is, it might be different. Okay, so it is used to predict the future value based on the previous observed value. So one thing which we are going to say, which I already told you, that what would be the tomorrow's stock price value is not just dependent on what is the date tomorrow, right? But it is dependent on what was the stock price value of today, or what might be the stock price value of the yesterday's. So Sunil is saying, what is the difference between supervised analysis and time series analysis? Sunil, both time series analysis is also a supervised algorithm only. But here we are getting little bit, one thing we are fixing, which is here, two things we are fixing here. One is that it is independent variable, right? So one is that time is the independent variable. And second value we are saying is that tomorrow's value would be dependent on the today's value, means whatever is the dependent variable here we were having, right? So till now what was happening, that dependent variable was depending on the independent variable, but now we are saying dependent variable is not only dependent on the independent variable, but it is depending on its previous value as well, right? Like if I am talking about the stock value, right? So it is not only that what is the what day it is, but it also depends what was yesterday's value, right? So that's the whole thing. Okay, so Bengali Babu is saying, will you show some code or just PPT? Yeah, we are going through, we will have the codes as well. Okay, so let's go here further. Okay, and let's go here further. And there are different kind of things which we can do using the time series analysis, but still you will see these are very much interrelated. For example, what, so one of the important part is like business forecasting. I might want to know how much, let's say if I have a sweet shop, right, and Diwali is coming, so I might be interested in forecasting how much sweets would be sold during the Diwali days. So this way, if I can do the correct business forecasting, so accordingly I can prepare the sweets properly so that we get the maximum benefit. Similarly, it is about understanding past behavior, right? So sometime when we are doing the time series analysis, then we are also looking why happened something past, right? And using their past behavior, aim is again that we want to understand that what may happen in the future, right? So for example, we might do, even though we want to predict what would be this Diwali, sweet sale for my let's say sweet shop. But how I am doing this thing is by looking into the past behavior. I look how much sale on the Diwali happened on the last year, how much sale of the sweets happen on from the last to last years, and accordingly by looking into this pattern only I will do the business forecasting. So it is also equivalent that we are doing the we are trying to understand the past behavior. And while when we do the business forecasting, what we do with this, we do the future planning, right? So I understand, okay, 20 kg sweets need to be prepared, let's say a particular sweets, then I need to plan the things in advance, that how much raw material I need to buy and when I should start making it. Let's say it takes 2 days to make 10 kg sweets, right? So accordingly I can plan, okay, 4 days because 20 kg is the business forecasting, and it takes 5 kg per day. So 4 days before the Diwali, I should start preparing my sweets. It also helps us in evaluating price, right? current accomplishment. Again, it is nearly same thing. Let's say I forecasted that business that it would be around 20 kg sales would happen, but it happens only 15 kg, right? So we can evaluate our accomplishment. So it happens 15 kg compared to 20 kg. It means something might go wrong there. Sorry. So this way we can evaluate also our accomplishment, or we might look then why it happens. Maybe I didn't decorate my shop properly to attract the customer properly, while the other shops were very nicely decorated and so on, right? So now let's see components of the time series. So what are the different components of the time series? So there are four different components are there. One is trend, next is seasonality, then irregularity and cyclic. So let's talk about one by one about each of them. So what is trend? Trend is something which is happening over a long period of time, right? And same thing is happening. Same thing is like, maybe if I'm talking about stock price, let's say I have taken for a particular company stock, and stock is keep increasing, right? So overall it keeps increasing, right? So something is happening gradually, and that is happening for longer period of time. It might be increasing or it might be decreasing, right? So whenever it is increasing, we call it as a uptrend, and if it is decreasing, we call it as a downtrend. And if it is going horizontal, right, it is neither decreasing nor increasing, but it goes nearly horizontal, then we call it as a horizontal trend, right? So trend is about something which comes and in the trend, and that whatever is happening continuously, whether sale is increasing continuously or sale is decreasing continuously, whatever it is, right? So this is what we know as the trend. Then next one is the seasonality. What is seasonality? Seasonality is all about repetition during a particular time period only, right? So for example, if I talk about the sweet sales only, right? So as I have been saying, let's say I have a sweet shop, right? Do not ask me at the end how much I will sell it to you. Just kidding. So let's say we are taking the example of sweet shop, right? And here we make, let's say this is January month, this is February month, this is March, then we have April, May, June, July, August, September, October, November, December, right? So let's say this is for some particular year, 2017, let's say, right? And then again, January, February start happening, January, February, March, and this time it start happening for the 2018, right? So what we are going to see here when we are talking about seasonality will come into a little bit more detail. So during the month of January, let's say my sale is not much. Then during the month of February, it is not much. But during the March, because of the holy festival, suddenly the sale was increased, and then after that it is again normal. Then during the month of August, during Raksha Bandhan, again this time sale increased, right? And then it goes normal. Then after some time, then Diwali come, and during the Diwali, it is so much sale, right? Sorry, I make it. Do we have here rubber as well? No, we have the one method that is erase or drawing. So we take, let's say during the Diwali it happens, then it comes during the December, that is Christmas, sale was there. Then again it becomes the same way, and during the March again it show the same kind of pattern, and then it again goes, and again during the month of August it again show the same pattern. So what you can see, the same pattern is being repeated during a same period of time around, right? So for example, during the March sales show this kind of pattern around, during the August sales show this kind of pattern, during the November sales show this time of pattern. Or we can see pattern is repeating itself during a particular season only, right? So this is depending on the season, that during a particular season, a particular kind of sale is there, right? So pattern is being repeated, right? So on the basis of season we can say, or similarly you can take the sales of woolen cloth, right? So every winter sales of woolen cloth increase, and during the summer sales of the woolen cloth decreases. So pattern is same nearly here, right? So whenever we have the fixed time period, then we say pattern is repeating itself after the fixed time period. And when it is so the case, then we call it as a seasonality, right? Because during a particular season, it is showing a particular kind of pattern. Then we have the irregularity. Irregularity is something completely random, right? Things are happening randomly, right? So sometime it becomes 20, then suddenly it becomes 40, then suddenly it becomes 15, then sometime 12, and suddenly it changes, right? It is completely erroneous. If we can say randomly things are happening, that we call such kind of components we call as a irregularity. Then we have the cyclic component. Now, what is the cyclic component? So what is the cyclic component here? Cyclic component again means that pattern repeats. Like in seasonality, we were saying pattern repeat itself after some fixed time period. So with the cyclic component, it is same only that it repeats itself, but the only difference is that the time period is not fixed, right? While in the science seasonality, time period is fixed, but during for the cyclic data or cyclic component, time period is not fixed. So mostly you will see in the stock market data, it is mostly the cyclic data, right? It goes up down, but when it will go up and when it will come down, we cannot know in the advance, right? So that's the whole thing about it. And now let's go to the next slide. When not to use time series analysis. So there are two things when values are constant. If values are constant, they are not changing at all. So it means we doesn't need time series directly. We know exactly, okay, it is constant value. It is the same value always, right? So we doesn't need the time series analysis. Similarly, when values in the form of function, let's say it is completely following one particular function. Let's say it might be sine function, cos function, or whatever, right? So for that case also, we doesn't need to use time series analysis specifically. Directly we can just find that particular function fx, right? Fx function is completely dependent on the x. We use time series value when we say this value is not only dependent on this, it is dependent on this as well as it is dependent on the previous value, maybe previous 1 day value or maybe previous 2 days value, right? So accordingly we choose this thing, right? So this way we can work around here, right? And then we have another thing. Stationarity is one of the important concept when it comes to time series analysis. So what is stationarity? Stationarity, time series has a particular behavior over time, and there is a very high probability that it will follow the same in the future, right? So whatever behavior it is showing now, we are thinking it may show the same thing around in the future, right? So when we say the stationarity, when our data is stationarity, we say it is having a constant mean, it is having a constant variance, and auto covariance is there. That doesn't depend on the time. Actually, this is written wrong. How to remove, not how to remove stationarity, but how to convert data into the stationarity data, right? So many times it happens that our data is not stationarity. We need to convert that data into the stationarity data. We will see how to do this thing. So we are going to check for the stationarity. How we can check the stationarity? So one thing we have looked here already, they have the constant mean and constant variance. So what we can do here, whenever we have to check whether the our data is stationary or not, we can calculate their average and variance over period of time. Maybe every week average we can see, and then we can see how the average is changing over a period of time. If average is nearly constant, then we say it is average is nearly constant as well as variance is also nearly constant. Then we say our we have the stationarity in our data set. Otherwise we will say no, it is not. And there is a one more test is there which we call as a Dickey-Fuller test actually, right? And Dickey-Fuller test, we will not go into the detail of it currently. Sorry, sorry guys. And Dickey-Fuller test we have as a test to find out whether our data is stationarity or not. And we will see with the help of Dickey-Fuller test, we will calculate the test statistics and we will calculate some critical values, and we will do some comparison between them, and according to the comparison between them we will reach to the conclusion whether our data is stationary or not stationary. Okay, and let's talk about what is ARIMA model. We are going to work with the ARIMA model, right? So when we work with the ARIMA model, we call it as a, there are two things we say. One, we say autoregressive model, and another is the moving average model, and we are merging both of them together. Model in both of these model we are merging together, right? So here let's see, let me take you here. Not much things are given, but let me tell you few things about these model. So as I told you already, that here time is given like t1, t2, t3, and so on. And here we have the value like y1, y2, and y3. Okay, so we calculate yt, right? How do we calculate yt? Yt is equal to some constant value plus summation. So there are two formulas. First of all, I am telling you about the autoregressive formula. So we write mu plus sigma summation over, we say, gamma I, that is the coefficient, right? So this is, we are saying I is equal to, let's say, 1 to p, and here we say y t minus I, and plus some kind of error term, right? So this is how do we apply our autoregressive model, where we are saying some constant value, some error is added, and this is what term is saying. This is showing how it is dependent on the previous value. Like if we see p value, if we take p value 1, it means we are saying y3 dependent on the y2. So yt minus I will become 1, so it become yt minus 1 multiplied by some constant here, coefficient actually, and the rest is this formula, right? Similarly, if we take p value 2, then it means we are saying y3 not only dependent on the y2, but it is also dependent on the y1, right? And then in this case, when we open this formula, we will be having some gamma I into y2 plus some gamma 2 into y1, right? So this way the value dependent. Similarly, if I write y4, then it is dependent on this, and it is also dependent on this. So this way it works, right? And there is little bit, this is our erroneous term, we can say, or irregularity. Little bit randomness is also added with the time. Okay, and similarly, when we talk about the moving average, so we are saying that yt is not only it's not dependent on the previous value, but it is dependent on the uh, that is previous errors terms, right? So this is how do we write it? We write summation is equal to I is equal to 1 to q. Again, we are considering earlier some q number of values, right? And then we will write here like gamma, in place of gamma, let's write different constant, which is theta I multiplied by our ret minus I, right? And this way we do the calculation for this one, right? And then definitely new would be added automatically, right? So this is the whole formula which we have for it, right? And when we talk about ARIMA model, we are basically merging both of these together, so it make ARMA model, right? And with this we are adding one more thing, that is I. What does this I represent? So our data is not actually stationary many times, so we need to bring it into stationary form. So when we do bring it in a stationary form, then we have to differentiate it, right? So this is how many times we need to differentiate our data set to make it stationary is being decided by this I, that is what we are saying, and the value we use here d. So p is how many autoregressive lag we are using, as I showed you in the formula. I is equal to 1 to p. In q, in MA, basically how many previous legs we are using, or we say moving average legs, and d basically how many times I need to differentiate my data set, right? So that's the whole thing here, right? So we here during this session we cannot go into much of the detail of each of these formula, but in a very well form these things are being also taught. But currently we will take you just telling you these very basic stuff. There are some other things which you guys need to know also, but currently we will keep it simple and take you through the now some practicals so that you can implement, you can do the implementations. Okay. So I have imported this pandas library as PD, and after that I'm writing df is equal to pd dot read underscore csv, right? And here the data set which we are taking is this BOE exude DLED, right? We will see what data set it is actually. Right? So on YouTube, somebody has asked, so one second, TensorFlow, okay, sorry, this was some different question. So in this type of case, feed forward networks will be suited. Pranay, currently we are not using neural network here, but we are using the ARIMA model here. Okay, so neural network is completely separate base. We deal with the, yeah, we can use the neural network also to do the time series analysis, but currently we are using the ARIMA model. And data set which is given to us is this one. This is basically the data set which is showing the €1 value in terms of dollar. So on to this particular date, like 2017 November 9, the €1 was equivalent to $0.8603. On this particular date, €1 value was around that much dollar. So that is being shown the currency equivalency, right? So let's say you want to make a model which can guess, which can predict that what would be the tomorrow's currency value and so on, right? So this is a model which we are going to implement here. Okay, so we are just seeing the top 5 rows currently, right? And if you want to see how many total number of rows do we have here, so we see we have around 10,837 entries are there, right? So that much data set is given to us, right? And so onto this data set, we will convert it into training and testing set as well, and then we will apply our algorithm as well. So first of all, let's do one thing. When I did this info, then we can see date value has been taken like a object, means string it is taking, and value has been taken like a float. So first of all, what we are going to do, we are going to change its data type to date time, right? So how we can change it, we write here df, within df we write the date is equal to pd dot to underscore date time, and then we write here what was the real value. So we are changing the data type of it, so that if I show you now df.info, then you can see what it is showing here is the data type has been converted into date time, while earlier it was data type was object, right? But if I show you the data will look exactly the same way if I print, right? There is no difference in looking into here, but data type internally has been changed. So what we are going to do, we are going to make a series. This is our data frame, right, where we have these two columns. So what we are going to do, we will make it first of all as an index, and then we will make it as a series, right? So for making it simply as index, let's first of all, yeah, make this df dot set index, right? So what we are want to set the index as date. Let's call the it as a index df. So we store it into a index df, so that if I now show you dot head, then what you can see here, earlier index was 0 1 2 3 4, but now index has been made as a this date column only, right? So this has been made as an index. Now I can take it as a series. So I take here, I convert it into series in very normal way. I write time series is equal to index df, and here I write value is the one which will come into my value. So if I show you TS, this is my time series, right? So that become my series only. This is on this particular date, this value, this particular date, this value, and so on, right? So let's just keep top 5 values. Okay, now let's visualize the data. So for visualizing data, let's import first of all matplotlib dot pyplot as plt, and then we can write plt dot plot, and then we can write ts, which is our time series data. So you can see this is my data set, right? So during 1975, this was the €1 value. You can say earlier €1 value was less, then it is reducing during 1980, then during 1985 the €1 value increased to around that much dollar, around $1.5 something. Then it started decreasing, and again it is being shown. And during till where the data is, which is around 2017, is this value, right? So this is my data. We are drawing it how the value of euro in terms of dollar has been changed from 1975 till 2017, right? So if I ask you that is it stationary data, it doesn't look like stationary data, right? So we'll be seeing also, we'll be doing the calculations also, but by looking also it does not look like, and some of you might say why so. We will see exactly. But to make the data little bit more smoother, we will have the same pattern, but we will make it little bit more smoother our data set. So we will take weekly data, right? And we will resample our data over a week, so that the error or irregularity which we have into our data set would be somewhat reduced, so that every week data we are taking mean, and we take for each week we are taking one data point, right? That is mean for that. So you can see 1975 January, 5th January, this was data value. Then we are taking after 7 days, that is the 12th January, then 19th January, then 26th January. So we are taking it weekly data, and for each week we have basically taken the mean, right? So let's just show the 5 values. Right now we are going to check for the stationarity. For checking for stationarity, for so Pranam Mathur is saying euro was not discovered in 1975, I guess. I think, yeah, I think you are right. Chances are high. Maybe they might have their own dollar. They this Europe, right? I think they were also having a dollar probably, but might be they have their own dollar. I don't remember, but I remember their value currency changed sometime to euro, right? And during that time period, they, like, we have the Canadian dollar, we have the US dollar, right? And both have the different values. Similarly, it might happen with the Europe currency in terms of dollar. Okay, so let's go for testing stationarity. We are going to define one function, right? So let's define test stationarity, and here we will be taking the data, our time series data, and then within this particular function, we are going to do the check the stationarity, right? So how do we calculate, how when we say our data is stationarity, we say if the mean and standard deviation is constant over a period of time, right? So we will take first of all rolling mean, we will calculate. So how do we calculate it? We write time series dot rolling, and within this function we say window is equal to 52, right? Why we are doing window is equal to 52? Because in an year, how many days do we have, how many weeks do we have, is 52 weeks, right, around. So that is why we are taking here, so that year mean we can take 52 weeks, so that we can take year wise, because our data we have taken in a week form. So here we are taking nearly every week mean, right? And similarly we calculate the rolling standard deviation, and here we write roll std and in place of mean we write the standard deviation. Sorry, we need to do a lot of few more stuff, so let's plot them, right? So we can say original one is equal to plt dot plot. So we basically draw the original data, we get define its color, let's say blue, and then we see the label is, let's say this is original, so we write it original, right? Similarly we do the mean plot is equal to plt dot plot, and this time we write roll mean, and then its color we can take, let's say red, and then we take the label, let's say rolling mean. Similarly we do the standard deviation plot is equal to plt dot plot, and we write rolling standard deviation, we write color is equal to black, and then we have the label is equal to, we say rolling standard deviation, right? So this is our plot, and we can write, let's say legend, so that it can, so that we can draw it. So plt dot legend location is equal to best, right? So automatically it show the legend. I will tell also what it is doing, and after that let's write plt dot show, right? So let's do first just drawing this graph so that we can know our data is stationary or not, right? So if we write here test stationarity, and if I send my data set here, which is ts underscore week, right? And here we can see this is blue color is our original data, and this red color curve is showing our mean over it, right? So how the mean is changing with the time, and this black color is showing the standard deviation, right? So this is, we can see here legend, blue original, red rolling mean, black rolling standard deviation, right? So we can see our data is not stationary because mean is not stationary, right? Mean is changing, standard deviation somewhere we can think is not changing much, right? Yeah, it is not exactly horizontal line, but little bit change is fine. But in the mean we can say there is a too much change is happening, it means our data is not stationary, right? Other ways also to find out the stationary mathematically also there, we use the Dickey-Fuller test, but currently I will not like to show you the Dickey-Fuller test here, because if we do the Dickey-Fuller test, understanding it would be little difficult currently in a small lecture. So a lot of things we are I am taking away also here, but I will show you at least that much thing, so that yeah, here by looking into the graph you can say whether this is stationary or not, right? So this is not stationary actually, right? So let's make our data stationary, and one of the good way is that whenever we have the data, so that calculations can be done in a small way, we can take the log of our data, right? So let's take log of our data, that is ts week underscore log is equal to np dot log. We need to import the np before that, that is import numpy as np, right? So we have converted our data into log form. Now if our data set is not stationary, so we can convert it into stationary, how? By differentiating it, right? So for example, if my equation is y is equal to mx plus c, right? So if my data is, if something is there like y is equal to c, then it is a constant value. But if something is y is equal to mx plus c, it is not going to be constant, it is not going to be stationary. But if I differentiate it, if I write dy by dx, then it would be what? It would be m, right? And then in this case this become a stationary. So we are going to do the same thing. If our data is not stationary, we will differentiate it, right? And if it is mx square, in this case it will give us first of all mx, and then if we second time if we do the differentiation, then we will get the m, right? So we keep doing the differentiation until we get our data as a stationary, right? So one of the good ways definitely Dickey-Fuller test, which we are not seeing here for finding whether data is stationary or not, but currently we are using our eyes by looking how much variations is happening into our mean and standard deviation, right? So red color curve showing too much, and now we are going to convert it into stationary by doing the by taking the differentiation. And how do we take the differentiation? What is the formula for delta y? Is nothing but we say yt minus 1, right? So this is how do we do the differentiation, right? Where this is a very small value, right? So let's do the same thing. So we are going to differentiate our data set. So it is we say ts weak log differentiation is equal to ts weak log minus ts weak log dot shift, right? So what we are doing here, so let's say if our data point values are like this, let's say 10, 11, 12, 13, 14, right? So it is not stationary currently, right? But if I shift it, right, one value I shift down, right? So one value I shift up, so this go up, this go up, this go up, this go up. So what it would be? It would be 11, it would be 12, it would be 13 here, it would be 14 here, it would be 15, right? And then from this I subtract this thing, or if I do it downshift and subtract from it, it would be, so what it would be? It would be 1, it will come as a 1, it will come as a 1, it will come as a 1 if I am doing the subtraction here between them, right? From this to this, right? So this way I can see here my data is becoming nearly stationary only, right? There is less changes we will find because of this, right? After differentiating it, still if it is not there, then again differentiate it, right? So this is what we did with the shifting. We shifted it, right? So we get here this, we differentiated, and now we can see, we can also, there might be, we get also some null values into it, so we drop the value. We can write in place is equal to true rather than storing it again. Here we TSV clock difference, right? And then we can plot also. We can do the plotting of this graph as well. We can check also the there. We can also, this is this become our data set, right? So now let's check that whether this becomes stationary or not, right? So if I now do the test stationarity and we pass over this TSV clock difference data, then we can see this red color is coming as our, now not much changes is happening within our red color graph as well as this black color, right? Little changes are there, very small changes are happening. You can see this is 0 and this is 0.02, this is 0, this is minus 0.02. So you can see only very small changes happening, only of maximum 0.01 changes, right? That is a very small change happening in the mean. So we can say that mean is nearly constant. So is the variance in this case, which is being shown by the black color, right? And definitely best way is, again I will say, is Dickey Fuller test, but we will not do here this thing. We will keep it simple, right? Now we are going to apply the ARIMA model, right? So when we have, so one thing we got after differentiating my data set one, my data set become a stationary. So D value become 1. How many times I am differentiating my data set? That become its value. So I am differentiating my data set once. So D value become here 1, right? So one thing is decided here. But when we talk about the ARIMA model, there are two more values are there, right? One we call as the autoregressive, other we call as a moving average. So we have the legs for them, right? P and Q value, as we studied about the formula, right? So like Leju is also saying P and Q value, right? So there is a proper way of calculating the P and Q value. There are few graphs we draw and we do few things. We study some formulas are there. We call them ACF and PACF, right? using which you can calculate those things. But currently I am not, I can't show those things again because of the time constraint. It will take a lot of time to go through that. So currently we will take the simple way. We will take the simple methodology, right? So we will use the simple methodology. We will use the ARIMA model so that you can apply your ARIMA model onto any data set, right? But you need to do little bit hit and try stuff also, the way with which I'm going to show you. But normally if you understand ACF and PACF, then you doesn't need to do those little bit hit and trial for P and Q values, right? But here we will do some small those hit and trial stuff. Okay, so let's do one thing here. So now we are going to divide our data set into, so now we are going to divide our data set into two parts, right? So one would be our training and one would be our testing part. So how we do divide? So normally till now, what way we were dividing our data set into, let's say this is the data set that has been given to us, right? So normally what we do, if I say what are the training set, then randomly some of the rows I choose for training set, right? Let's say these rows has been chosen as a training set, and the rest rows which are left, like these two, might be can be chosen as a testing set, right? Training and testing set. But here we were choosing them randomly, right? But in the in the case of the time series data, we cannot do these training and testing conversion randomly. Why so? Because let's say if I take this part as a training part, and after that stuff I am taking as a testing part, then it will not be good, because the testing part will require this training part, or this training part require its earlier values also as the part of the training set, right? So that is why we never randomly choose here our data set randomly. But what we will do here, till some part we will say this all is the training, and after that whatever data set is left is my testing set, right? So this is the way training and testing set divided into our time series data set. So let's say that we are choosing, let's say, the size for the testing as a 15 data points. Let's say last 15 data points we will take as a testing set. And so let's write our training set we are going to take. So training set, we will have everything from TS week log. So you see here, I'm not choosing here the differentiated data, but I am choosing the real data, because when we will be applying ARIMA model, I just need to tell itself that by differentiating it once, it would be a stationary data, so that ARIMA model will take care of it automatically. So that is why we are taking here undifferentiated data, right? And here we take till every data other than last 15 rows, right? So minus 15 means it will leave the last 15 rows. So that becomes my training set, and what is going to be my testing set is TS week log and the last 15 rows. So from last 15 rows we will take into the testing set, right? And here we are going to do one more thing, that is we are keeping our history, and in the history basically our training set we will keep into the history. So we say X, so we are creating a list in which we are storing everything whatever we have in our training set, right? Similarly, as we will do the prediction one by one, we will store that into a list, and the list would be my prediction list, right? So this is the way I have made my data set ready. Now we are going to apply our algorithm, right? ARIMA model. So for applying ARIMA model, we need to import first of all our ARIMA model. So how do we do it? We do it from stats model dot tsa dot sta tools, stat tools we have, stat tools we have, and from stat tools dot, no, this is tsa stat tools is not needed. We need to choose the ARIMA model, and then we import ARIMA. Right, so this way we import this. Right, so we have imported it and we will be building this model with that way. So we want to do 15 time forecasting, so we will be running it for loop for p in range, and we can say as many data point we have into our test set. We know already even though 15, we can write directly 15 there, and after that we create our model is equal to ARIMA, and within this what do we do it, we pass our history, we give the order. So order is what basically p d q values, right? So that is what is given into the order. So d value we calculated already, it is 1, we can write here 1. P and q we doesn't know, so let's take randomly 2 for p and 1 for q. But there are ways to calculation for them, but we can't do this thing here. But another way is that you do the hit and trial stuff here, right? So here you can try with different value of pq, like you may take 1 2, so always start with the 1 and slowly and gradually increase these values with the different patterns, right? So that is for the hit and trial currently. So Vivek Jain is saying, should you not consider the length of train? No. See how many time we need to do that we will do here, right? So that is why we are considering it test. We will see why, because every time I want to do prediction, I want to take the data set into consideration, right? That is why we are taking this thing. While for all the train data set, we will do it in a once, right? So let's see how we will do this thing. So let's say model which we are fitting and storing back into model fit, and we call model dot fit, and then we pass our we will pass our data set into it. So that is our train data set, right? No, we doesn't need to, sorry, more in the fit we doesn't need to do, and during creating the model ARIMA itself we pass the history, right? Within the history we have added the whole training set here, right? So we doesn't need to pass here separately. Okay, and after that we can calculate the output. So the next output it would be giving us automatically, if I write here model fit dot forecast, right? So it will just forecast the last value. If I am writing dot forecast, it will just forecast the next value, right? And then it gives us lots of value, but the real value is the one which is the predicted value is only at the 0th index of the output. So we are taking it as a real value, and then we see, let's say what is the, so we can add it into our prediction. So we write prediction dot append, so we append this particular value into our prediction, and after that we take the observation which is the real value, we take that is our test set, and we write it, that is our tth, right? That is obs as the real value. And after predicting the first value, we will append the that value for the next prediction, right? So what is the date? So if I want to predict tomorrow's, I will predict it using today's and the previous value. But if I want to predict day after tomorrow, for that I will be using the tomorrow's value, right? So that is why within the history we are appending the new observation, right? And after that we can print predicted value, right? So what is the predicted value which we have here? So that we write, so we can take x because we have taken the log, so we can write np dot exp, and that is within the y hat we have stored. We take also its float in case, even though this would be float only, let's leave it. And then we can write the expected value is equal to, and then we write np dot exp, and within this obs have the real value, right? So this way we can do the prediction, right? So if we execute this code, so it is showing here point predicted value is 0.855, but the expected value is 0.84. The next, the value which has been predicted by our system is 0.843, but the expected was 0.85. Then predicted is 0.851, and the expect value is 0.851. So very much nearly same only. So this way we can see how the different values has been predicted here, right? So now we can also look all the predictions value here. So if we see here all the prediction, then this is the way, right? So we can, rather than taking it, these all has been written as a array, right? So rather than making it as an array, let me just re-execute it. And before executing it again, let me do one thing here. By appending it, I convert it into a float value, right? So that it will not be coming as an array. So that we can apply our, so in the time it is being printed, let me import for checking the mean squared error. So from sklearn dot matrix, right? So what is from sklearn dot matrix? To complete import mean squared error, right? So that we can calculate the mean square error, right? So, and let's see now. So here if I print this prediction value, it would be plain list, right? So this is the first, second, these values are in terms of log values, right? So we have the result in terms of log value, so we can do in terms of that only. So we can calculate now mean squared error. I can pass my predictions as well as the test, right, which has the result, right? So it is giving us around 6.3 into 10 raised to the power minus 5, right? So that is very less, right? Because this is not 6 point, this is in reality 0.00006, something like that, because here we have the 10 raised to the power minus 5, right? So this is how you can apply the ARIMA model, right? So you can use this method, but yeah, there are few things which we didn't do here actually, which are little time taking as well, and which can help you in finding these value P and Q, right? So like P and Q, two things we didn't talk about, like ACF PACF we didn't talk here, as well as we didn't talk about the Dickey Fuller test, right? Which can help us mathematically to find out how much stationary our data is, right? So these are the two things which we cannot do here, but I hope so things are understood properly. You can apply in all this status this method maybe on to your some kind of stock data if you are interested, or same kind of stuff, right? So Pranay is asking, is ARIMA used extensively or just for series? For both are everywhere are getting used, right? So many places are pretty good. So Vivek says, how can we determine if mean square error value is good or not? That is how more the smaller the value is mean square error, but better it is. So how much mean square error you want into your system, that depends on you. Right? It is equivalent that if I say accuracy, how much accuracy I want in my system. Right? Sometimes for some application I might say I need 100% accuracy. In some system I can say okay, 95% accuracy is also pretty good. In some I can say 90% accuracy is good, right? So there is nothing as such. So like accuracy as bigger, it is good. Similarly, mean square error as smaller, as it is to zero, that much good it is, right? So depending on the application, that is completely. And definitely we want it to be right, if but that doesn't happen normally. Okay. Any other question, query do you guys have? Okay, Vivek is saying, how do we store time series data for quicker or efficient analysis? So Vivek, you want to say, let's say, like we are getting a real-time data, let's say stock data in real time we are getting, right? So how to work with such kind of data, where we have the past data as well as we are getting the as the data is coming. Is it so, Vivek? This is what you are saying? Yes or no, or something else? Yes, okay, great. So if this is the thing, then for that we say that we want to do real-time processing, and for that we use actually PySpark, right? So we use PySpark for that. Or whenever we have the used data set, then we use the Hadoop system or such kind of systems. It will be live plus store data. That is where we use the Hadoop plus PySpark, right? So that Spark help us in working with the real-time data as well as we can handle the store data as well with that. Okay, great. Any other question do you guys have? No question currently? Great. So we will finish the session now. Thank you very much, guys, for listening with so much patience. Let me know in I will be waiting for 20, 30 more seconds. Let me know if any query, anything else is there before I finish the session. Santosh is saying, awesome session. Thank you, Santosh. You are daily appreciated. That's a very good thing. Okay, I can see how much you are enjoying. That's great. Okay. Liju is saying, thank you. Yeah, you're welcome. Okay, great. So let's finish the session. Thank you very much, guys. And tomorrow we'll be discussing about the reinforcement learning. So if you guys are interested into this, please log in on time. So Vivek is asking, how can we apply time series for stock market analysis? Vivek, it is simple, same thing exactly. What is this data set, right? So like this is my data set where we have the date and the value, right? So it might be every moment you are getting data, or it might be date wise you are getting the data depending on which kind of way you want to do your analysis, right? So accordingly, you have to choose. Data set it is same way only. In place of fair value, like you might have if you are working with the TCS stock market, you might be having a TCS stock market, and here their values would be given, right? The rest process would be same only. Okay. But if you are asking for real-time data, for that you need to work with the PySpark. Actually, for that you need to learn Spark. But the same algorithm, if you use with the Spark, it will work greatly. Okay, John from the YouTube saying learn a lot. Thank you so much. Yeah, thanks for appreciating, John. I'm happy that you guys are finding them useful. Preetham is asking what is the use of FB profit? Where we did FB profit, something we did here. Abhishek saying thank you. Olio, yes. Okay, great. So let's finish the session. Okay, guys, bye bye. See you tomorrow with the reinforcement lecture. And I hope you found this lecture useful. You will be using it somewhere. Thank you very much. Bye bye. Take care.